Section 3.1, Graphing Linear Equations. Let's talk a little bit about the coordinate plane before we just jump into plotting points. The horizontal axis is called the x-axis. The vertical axis is the y-axis. Looking at the x-axis, to the right of 0 are your positive numbers, 1, 2, 3, and so forth. To the left, you're going to get your negatives, -1, -2, -3, and so forth. On the y-axis, your numbers that are positive are above 0, so 1, 2, 3, 4. And the negatives are below, so -1, -2, -3, and so forth. The coordinate plane actually is broken up into 4 quadrants, and they go counterclockwise. This is quadrant 1, quadrant 2, down below is quadrant 3, and to the right is quadrant 4. Now in quadrant 1, you should see that every ordered pair will have a positive x and a positive y. In quadrant 2, the x's will be negative, but the y's will be positive. In quadrant 3, both the x and the y will be negative. And in quadrant 4, the x's are positives, but the y's are negatives. One other important feature is where the x-axis and the y-axis intersect, which is the origin. So let's go ahead and plot the points. We'll label this first point A, B, C, D, E, and F. So A is -3, 2. Every ordered pair has x first and y second. So all points on the coordinate plane are written as ordered pairs. So x -3 and y 2 says go to the left 3 but up 2, and that would be point A. Point B says go to the left 5 and then down 2, so there will be point B in quadrant 3. 2, 0 says go to the right 2 but nowhere up or down, so you're actually going to be on the x-axis. You're not in a quadrant, so there is point C. D is 0, 4, so say go nowhere left or right but up 4, you'll be on the y-axis, not in a quadrant. E is 7, -4, so 7 to the right and then down to -4. So it's going to be right there, and that will be E. Lastly, F is 5, 8, so that says go 5 to the right and up 8. So there will be point F in quadrant 1. A linear equation in 2 variables is an equation that can be written in the form of ax plus by equals c. Where x and y are your variables, a, b, and c are just constants. So a, b, and c are real numbers. A and b are not both 0. You can't have a and b both being 0 because then you would not have a variable. This is considered standard form. So if you ever want to write an equation in standard form, you need to put it in the form of ax plus by equals c. A solution to an equation is one that when substituted makes the equation true. So how many solutions do we have to a line? Well, we actually have infinitely many because there's infinitely many points on a line. So there's going to be a lot of solutions. Let's look at example 1. It wants to know, is 312 a solution to y equaling 4x? Well, 3 would be my x value, 12 would be my y value. Plugging it in, I want to know, does 12 equal 4 times 3? And it does. Now, is that the only solution? No. There's lots of solutions, infinitely many solutions. So another one would be, say, what if x is 1? If I knew x was 1 and I plugged it in, we're going to get y being 4. That's another solution. What if I said x was 0? Plugging in 0, 4 times 0 is 0. You could go on and on doing this forever because there's infinitely many solutions. Let's look at example 2. Is 3, 4 a solution to y equaling 8 minus 4x? 3 would be my x, 4 would be my y. So I want to know, does 4 equal, put a question mark, 8 minus 4 times 3? Well, the left side's a 4. What does the right side turn out to be? It turns out to be 8 minus 12. So that's not true because 4 does not equal negative 4. So 3, 4 is not a solution. Can you tell me one that is? Well, let's plug in x being 1. If we let x be 1 into our equation, we're going to have y equaling 8 minus 4 times 1. 4 times 1 is 4, and 8 minus 4 is 4. So 1, 4 is a solution, but 3, 4 is not a solution. So if you want to know if something is a solution, plug in the x and the y value and see if it works. If it does, it's a solution. If it doesn't, it's not. There are 3 ways to graph a linear equation: the table method, the intercept method, and slope-intercept form. You can decide which method you like best, but I will kind of lead you down the path that I think, depending on how the equation is written, which method I would use. If you forget all other methods, go back to the table method, because the table method always works, it's just not always the fastest. First things first, you want to find at least 2 solutions. How do you find at least 2 solutions? You plug in an x value and another x value and find the y values that go with it. So you're just going to make a table. Now, normally we would want at least 2, because if you get 1 point right and 1 point wrong and you don't try another point, you might not get the correct line. So we're going to try actually 5, -2, -1, 0, 1, and 2. So we're going to try those 5 x values. We'll plug each one in and get a y value. Next thing you'll do on that one is you will plot the solutions on the coordinate plane and then draw a line connecting those points. So like I said, the table method is great, it always works, but it's not always the fastest. The intercept method. To find the intercepts, we need to understand that the intercepts is where it crosses the x-axis and where it crosses the y-axis. So if you're on the x-axis, y is always 0. So to find the x-intercept, you're going to be letting y equal 0. So your ordered pair will always look like an x, comma 0. To find the y-intercept, you're just going to be letting x be 0. Again, to be on the y-axis, x had to be 0. So our ordered pair for a y-intercept will always look like 0y. There's only one problem. If the points are the same, and the only reason why they'd be the same is if you got the origin 0, 0. If they're the same, then go back to the table method and try finding another point. If they're not the same, draw a line connecting those points. Now, when would I use the intercept method? I would use the intercept method when I'm in standard form. ax plus by equals c. If I am in this form, I'm most likely going to try the intercept method. If it fails, I'll go back to a different method. Now, the slope-intercept form is what most students like to use. However, if it's not in the right form, you might make a mistake putting it into slope-intercept form, so be very careful. If you're going to use slope-intercept form, you need to put it in y equals mx plus b. That's slope-intercept form. Now, what is the y-intercept? The y-intercept is b, because if x is 0, mx goes away. So to plot the y-intercept, it's going to be 0, comma b. Remember, to be a y-intercept, x has to be 0. Then you're going to use the slope, which we call m, to find another point on the line. Once you do that, you will draw a line connecting those points, and you're good to go. When would I use slope-intercept form? When I'm in that form of y equals mx plus b. So try different methods. Don't just assume that the slope-intercept form is always the best method. Try the intercept when you're in standard form. If you forget any of those, go ahead and try the table method. So let's try a few problems. Graph the following equations. x minus y equaling 2. I'm actually going to do the intercept method this time. And the reason why is because it's in the form of ax plus by equaling c. So I'm going to see if it's easy to find my intercepts. To find my x-intercept, all I have to do is let y be 0. So if I let y be 0, I get x minus 0 equaling 2. So my x-intercept is 2, 0. So I'll put a dot at 2, 0. Now, to find the y-intercept, I'm going to let x be 0. So to find the y-intercept, you're going to let x be 0. Plugging into the original equation, you get 0 minus y equals 2. So negative y equals 2. Multiply both sides by negative 1, so y is going to equal negative 2. So my y-intercept is 0, negative 2. Since I got two different points, all I have to do is now connect them. Put arrows on the ends because your lines continue going in both directions. And there's the equation graphed. Now let's look at number 2. 2x plus y equals 6. Again, it's in the form of ax plus by equals c. So I'm going to do the intercept method. To find the x-intercept, I'm going to let y be 0. When I let y be 0, I get 2x plus 0 equals 6. So 2x would equal 6, divide both sides by 2, and x is going to equal 3. So my x-intercept is 3, 0. So putting a dot at 3, 0. Now, to find the y-intercept, I let x be 0. So to find the y-intercept, plug in x being 0. When I plug in x being 0, I get 2 times 0 plus y is supposed to equal 6. 2 times 0 is 0, so I just get y equaling 6. So my y-intercept is 0, 6. Nowhere left or right, but up to 6. I'll connect those. Again, putting arrows to show that I'm going both directions. Now, what if I wanted to put it in y equals mx plus b form instead? Do I still get the same answer? To put it in slope-intercept form, I would subtract 2x on both sides. Those are not like terms, so y is going to equal negative 2x plus 6. If you like this method, just know how to use the slope and the y-intercept. This is in the form of y equals mx plus b. B is the y-intercept, so there's my 6. Now my slope is negative 2, and it's really negative 2 over 1. The negative 2 tells me to go down 2, and the 1 tells me to go to the right 1. But from where? From my starting point of my y-intercept. My y-intercept was 6. Down 2 to the right 1. And you can continue doing that over and over again. So you will see you get the same exact line. So if you like y equals mx plus b form, slope-intercept form, just make sure you put it in the correct form when you're getting y by itself. Number 3. 3x plus 4y equals 24. Again, because it's in the form of ax plus by equaling c, I'm going to use the intercept method. So again, how do we find the x-intercept? To find the x-intercept, we let y be 0. When we let y be 0, you get 3x plus 4 times 0 equaling 24. Well, 4 times 0 is 0, so I just get 3x equaling 24. When I divide by 3 on both sides, I get x equaling 8. So my x-intercept is 8, 0. So put a dot at 8. Now, how do we find the y-intercept? Well, to find the y-intercept, we're going to let x be 0. If I let x be 0, I get 3 times 0 plus 4y is supposed to equal 24. 3 times 0 is 0, so 4y equals 24. Divide both sides by 4, so y is going to equal 6. So my y-intercept is 0, 6. Connecting those, putting arrows, because it goes on indefinitely. There's the graph of the line. So now let's look at number 4, y equaling 5x. If you notice, this is actually in the form of y equals mx plus b. Only thing that's not there is the b. So what is that? B then has to be 0. So my y-intercept is 0, 0, since b is 0. My slope is 5, and it's a positive 5 over 1. So I'll start at my y-intercept, 0, 0. The 5 would tell me to go up 5, and since 1's positive, I'll go to the right 1. So from 0, I'll go up 5 over 1. If you want to do it again, you can, up 5 over 1. Connect those 2 points, and you have your line. What if I look at that problem and I don't see that it is in y equals mx plus b form? What if I just go back to the table method? The table method says we'll plug in -2, -1, 0, 1, and 2. Plug those values in for x and find y. So when I plug in -2 for x, I get y equaling 5 times -2. Well, 5 times -2 is -10. When I plug in a -1 for x, I get 5 times -1, which gives me a -5. If I plug in a 0, I get 5 times 0, and 5 times 0 is 0. So you could continue going, but look, we have some points that we could plot. 0, 0, got it. -1, -5. Does it give us the same exact line? Yes. So as you can see, it doesn't matter which method you use. You'll get the same line. So now let's look at number 5. Y equaling -2/5 x plus 3. Looking at that, we see that we are in the form of y equals mx plus b. So b is the y-intercept, so the y-intercept has to be 0, 3. So put a dot at 0, 3. Now we'll look and find our slope. Our slope is -2 over 5. The -2 would tell me to go down, the 5 would tell me to go to the right. So from the starting point of 3, my y-intercept, I'll go down 2 and to the right 5. So down 2, right 5 would give me that next point. I'll connect them, draw my arrows, and there's the equation of my line. Now looking at number 6, that looks a little weird. It says y equaling 7. So you have a one variable equation, not 2 anymore. So let's think about what that means if I looked at a table. If I looked at my table, y is always 7. It's never going to change. So it doesn't matter what x is, because y is always going to be 7. So if I plot -2, 7, there's a point. -1, 7. 0, 7. 1, 7. Do you see what kind of line I get? I get a horizontal line. So anytime you have a one variable equation and it's with a y equals, you know it's going to be a horizontal line. But what about number 7? Number 7 has 2x minus 6 equals 0. You still only have one variable, but you don't know what it is yet. So let's go ahead and solve for x. To solve for x, I'm going to add over the 6. So 2x is going to equal 6. When I divide by 2 on both sides, I get x equaling 3. You only have one variable. So again, looking at the table, what does that mean? X is always going to be 3. So it doesn't matter what y is, because x is always 3. So let's plot 3, -1. 3, 0. 3, 1. 3, 2. What you'll notice is you will then have a vertical line instead. So when you have a one variable equation with x equals, you get a vertical line. But if you have y equals, you have a horizontal line. I don't know how you want to memorize it or understand it, but somehow you have to get in your mind that if you have a one variable equation, it's either horizontal or vertical. So I like to use HOI and VUX. The HOI stands for H is horizontal, so there's your horizontal. So anytime you have HOI, you'll have a horizontal line. We're going to talk about the slope. The slope is going to be 0, and it's going to be in the form of y equals. So anytime you see just y equaling a number, you're going to have a horizontal line, the slope will be 0, and it has to be in the form of y equals. If you see VUX, you're going to have a vertical line. We'll talk about the slope more, but when you see the U, that's undefined slope. So vertical lines have undefined slope, which we'll talk about in the next section. And it's always going to be the form of x equals. So back to vertical lines and horizontal lines. Horizontal lines are going to have just y. Vertical lines will have just x. So be careful when you have a one variable equation.